In the world of modern manufacturing, precision is paramount. Industries demand components with intricate designs and tight tolerances. Wire EDM, or electrical discharge machining, has emerged as a game changer, offering unparalleled accuracy and efficiency. From aerospace to medical, automotive to toolmaking, wire EDM is transforming how we build the future. Its ability to cut complex shapes in even the hardest materials makes it an indispensable tool for industries where precision is non-negotiable. This essay will delve into the intricacies of wire EDM, exploring its process, advantages, and wide-ranging applications. We'll also examine why Erodex, with its cutting-edge technology and commitment to excellence, has become a leading name in providing wire EDM solutions. Join us as we unravel the intricacies of this revolutionary technology. Wire EDM is a non-traditional machining process that uses electrical discharges to shape materials. Unlike conventional methods that rely on mechanical force, wire EDM harnesses the power of electricity to erode material with exceptional precision. Imagine a thin, electrically charged wire moving through a block of metal, guided by a pre-programmed design. This process, often compared to cutting butter with a hot knife, allows for the creation of incredibly intricate shapes and delicate components. It is particularly well suited for working with hard metals like titanium and hardened steel, which are difficult to machine using traditional methods. Let's break down the wire EDM process step by step. Wire EDM, or electrical discharge machining, is a highly precise method used to cut intricate shapes and fine details in hard materials. This process is essential in industries where precision is paramount, such as aerospace, medical device manufacturing, and tool and die making. First, the workpiece is submerged in a bath of deionized water, which acts as a dielectric fluid. This fluid is crucial because it helps to control the electrical discharges and cools the workpiece during the cutting process. The dielectric fluid also serves to flush away the eroded particles, ensuring that the cutting area remains clean and free of debris. A thin, continuously fed wire, typically made of brass or molybdenum, then travels along the desired cutting path, guided by a CNC, or computer numerical control system. The CNC system ensures that the wire follows the precise path programmed into the machine, allowing for the creation of complex shapes and fine details that would be difficult or impossible to achieve with traditional machining methods. As the wire approaches the workpiece, a series of controlled electrical discharges, or sparks, occur between them. These sparks are generated by a high-frequency electrical current that passes through the wire and jumps across the small gap to the workpiece. The frequency and intensity of these discharges can be precisely controlled to achieve the desired cutting effect. These sparks, generated in a gap just a few thousandths of an inch wide, create intense heat that vaporizes minute particles of the material. The heat generated by the electrical discharges is so intense that it can melt and vaporize even the hardest materials, such as titanium and hardened steel. This allows for the creation of extremely precise cuts with very fine tolerances. The deionized water acts as an insulator and coolant, flushing away the eroded particles and ensuring a clean, precise cut. The water also helps to prevent the wire from overheating and breaking, which is essential for maintaining the accuracy and efficiency of the cutting process. The result is a smooth, burr-free finish with incredibly tight tolerances, often measured in microns. This level of precision is essential for applications where even the smallest deviation can have significant consequences, such as in the manufacturing of medical implants or aerospace components. Wire EDM is a powerful tool that enables the creation of complex, high-precision parts with unmatched accuracy and consistency. Section 4. The advantages. Why choose wire EDM? Wire EDM boasts a unique set of advantages that make it a preferred choice for a wide range of manufacturing applications. This technology has revolutionized the way we approach precision cutting and machining, offering unparalleled benefits that are hard to match with traditional methods. Let's explore some of its key benefits. Unrivaled precision. One of the standout features of wire EDM is its ability to achieve incredibly tight tolerances. This precision is often down to 1/10,000th of an inch or less, making it ideal for applications where exact measurements are crucial. Wire EDM stands out for its ability to achieve incredibly tight tolerances, often down to 1/10,000th of an inch or less. This level of precision is not just a luxury, but a necessity in many industries. This level of precision is essential for components used in aerospace, medical devices, and other high-performance applications where even the slightest deviation can be critical. In the aerospace industry, for example, the components must fit together perfectly to ensure the safety and efficiency of the aircraft. Similarly, in the medical field, devices such as surgical instruments and implants require exact dimensions to function correctly and safely. No mechanical stress. Unlike traditional machining processes that involve direct contact and cutting forces, wire EDM is a non-contact method. This means that the tool does not physically touch the workpiece, eliminating the risk of mechanical stress and deformation. The electrical discharges remove material without exerting any mechanical stress on the workpiece. This is particularly beneficial when working with delicate or brittle materials that could be damaged by conventional machining methods. This is particularly important when working with delicate or brittle materials that could be damaged by conventional machining. For instance, materials like ceramics or glass, which are prone to cracking or breaking under mechanical stress, can be precisely cut using wire EDM without any risk of damage. Cutting hard materials? Wire EDM excels at cutting extremely hard materials that would pose a challenge for traditional tools. This includes materials like hardened steel, tungsten carbide, and even exotic alloys used in high-tech industries. The hardness of the material has little impact on the cutting speed or efficiency of the process, making it ideal for shaping hardened steel, titanium alloys, and other high-strength materials. This capability opens up new possibilities for manufacturing complex parts from materials that were previously considered too difficult to machine. Minimal material waste. Another significant advantage of wire EDM is its efficiency in terms of material usage. The process is designed to remove only the necessary amount of material, which minimizes waste and reduces costs. The wire EDM process is incredibly efficient in terms of material usage. The thin wire used in the process removes only a small amount of material, which not only minimizes waste, but also reduces the overall material costs. The thin wire removes only a small amount of material, minimizing waste and reducing material costs. This is particularly important when working with expensive metals or materials, where every bit of material saved translates to significant cost savings. This is particularly important when working with expensive metals or materials. In industries where materials like gold, platinum, or specialized alloys are used, the cost savings from reduced waste can be substantial. Wire EDM not only ensures precision and efficiency, but also contributes to more sustainable and cost-effective manufacturing practices. Section 5. Wire EDM in Action Industry Applications. The versatility and precision of wire EDM have led to its widespread adoption across numerous industries. This technology, which uses a thin electrically charged wire to cut through metal, offers unparalleled accuracy and the ability to create complex shapes that would be difficult or impossible with traditional machining methods. Let's take a closer look at some of its key applications. From aerospace to medical, automotive to tool and die making, wire EDM is revolutionizing the way we manufacture critical components. Aerospace. In the demanding world of aerospace, precision is paramount. The components used in aircraft must meet stringent standards for safety and performance. Wire EDM is used to manufacture critical components such as turbine blades, engine parts, and structural components. These parts must withstand extreme conditions and perform reliably over long periods. Its ability to create complex geometries and achieve incredibly tight tolerances makes it indispensable for this industry. The precision of wire EDM ensures that each component fits perfectly and functions as intended, which is crucial for the safety and efficiency of aircraft. Medical. The medical industry relies on wire EDM for the production of surgical instruments, implants, and other medical devices. These products must meet the highest standards of quality and hygiene. The process's ability to create intricate shapes and maintain exceptional hygiene standards makes it ideal for these applications. Wire EDM can produce the fine details required for surgical instruments and implants, ensuring they perform their functions with precision and reliability. Automotive. As the automotive industry strives for greater fuel efficiency and performance, wire EDM plays a crucial role in shaping engine components, transmission parts, and other critical systems. The precision of wire EDM allows for the creation of parts that fit together perfectly, reducing friction and wear, and improving overall vehicle performance. Tool and die-making wire EDM is a cornerstone of the tool and die-making industry. This industry requires tools that can create precise and consistent parts, and Wire EDM is up to the task. It is used to create punches, dies, and stamping tools with intricate shapes and precise dimensions. These tools are essential for mass production processes where consistency and accuracy are key. The process's ability to cut hard materials makes it ideal for creating tools that can withstand the rigors of high-volume production. Wire EDM ensures that each tool is made to exact specifications, providing the reliability and durability needed for industrial applications.